In this video we are going to talk about static equilibrium. So I have got a problem which is saying a thin rod 1 meter long has masses of 1 kg and 1.5 kg hanging at its end. Find the point at which the rod can be lifted without the rod tending to rotate. I assume the weight of the rod to be negligible. See the figure below. So the total distance from this point here to that point is 1. So if this is x, okay, meaning that the remaining part will be 1 minus x, of which x we don't know. I hope you get the logic there. This, if everything here is 1, and then x, we have x here, so to find the remaining one is 1 minus x. Okay, so this is w1, okay, and that's w2. Now I will keep on mentioning this whenever I make a video under static equilibrium. Static equilibrium, there are only two conditions which you have to know. The net force is 0, and the summation of all the torque is also 0. But the net force we are talking about, the summation of all the forces in x direction is equal to 0, and the summation of forces in y direction is equal to 0. So if you have been given a question which involves angles only and there is no distance, then you are going to use that question to just find the missing variables using the first condition. The net force is equal to 0. So you will just be using the summation of forces in x and y. That's all. If you have been given the question that involves the distance and there are no angles, you are going to use the summation of torque. If the question involves both the angles and the distance, then you are going to use the combination of these two. So like this question which I have here, I only have distance, so then I'm going to focus on torque. Okay, so we do know that torque is basically force times the perpendicular distance. Okay, for example, if this is the force here, the perpendicular distance will be this one. Okay, so this is my pivot. So our goal is to find the value of x in this case. That is the distance they want us to find. Okay, now one thing we should know is that 1.5 kg block will be pushing this system to move in that direction. Let's call that torque 1, but this other one will also be pushing it to move in that direction to make it balance. I'll call that torque 2. So one thing we should know is that clockwise, or you say the summation of torque should be equal to 0 if you want, the summation of torque should be equal to 0. What torque do we have? We have got this torque, so you can assign anything. You can say this should be positive, this should be negative, but you end up having the same answer even if you swap them. So if T1 will be positive minus T2 being equal to 0, shift torque 2 to the other side, you have this. So torque, okay, torque is force times distance. So I'll say, what is the force? It's the weight force. So I'll say W1 times the distance should be equal to W2 times distance. But what distance are we talking about here? And what W1 are we talking about? The W1 is M1G. The distance we are talking about, the perpendicular distance from the pivot all the way to where W1 is x. That is the perpendicular distance. So we have x should be equal to, this will be M2 times G, then the distance is 1 minus x. 1 minus x, like that. So now we do not have mass, or we have masses, okay, but we can cancel G. We have G both sides. So we can say that M1 times x will be equal to M2 then 1 minus x. like that. We plug in the values. What is m1? So m1 is 1.5, okay, times x being equal to m2. What is m2? M2 is 1.0, open brackets, 1 minus x. So it will be 1.5 x being equal to, if I multiply this, will be 1.0 x, 1.01, then we'll have minus x. Shift this to the other side, it will be 1.5 x plus x being equal to 1.0. If we add these two, we'll get 2.5 x being equal to 1.0. So you can divide both sides by 2.5, 2.5. Therefore x will be 1 divided by 2.5, that is 0.4. So it has to be placed 0.4 from the pivot. Okay, so the answer here is 0.4. Now one thing we have to understand is that this 0.4 is just here. Okay, so for you to find this distance, it is now 1.1 minus x, which is going to be 0.6. Okay, there is nothing difficult about this question, and I think I've solved different questions under this topic. So I would request you guys to go back and also watch my videos on website under the same topic. Then the last question is saying, state the condition of translation. So translation is something that is moving, is either in x direction or in just y direction. So the condition is that the summation of the forces, okay, the condition is that the sum of the external forces should be equal to 0. That's the condition of translation. So you have got the summation of forces in x should be equal to 0, summation of forces in y should be equal to 0. So you just say the summation of all the forces, or the summation of the external forces, should be equal to 0. That's all. Okay.